Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video, we're looking at the 2025 exam paper and we're looking at question 7, part A. Shauna wishes to take a tour of Connemara. While deciding her route, she uses a road map to draw the network shown below. The weight of each edge represents the distance in kilometers between each location. Use Dijkstra's algorithm to find the shortest part from Utrecht to Cleggan. Calculate the length of the shortest path. Relevant supporting work must be shown. Okay, so here is this seems like on the face of it a very straightforward Dijkstra's algorithm question. However, please note where we are starting and where we are ending. So our starting point is over on the right hand side. So this is our starting point, and then we end over here in Cleggan. So another feature here that's quite unusual is the use of the full names as opposed to letters, which is something we tend to see more for Dijkstra's algorithm. We see it simplified. Now, you could say, could we just use the first letter of each? But just be aware if you do that, we have a lot of overlap. So we have two L's, we have three C's, we have three R's. So if you're going to shorten this, we just need to be really, really careful. Okay, I'm going to use the list method here to do Dijkstra's algorithm. I find it's much more efficient. We don't really have space on the graphs to work. It's very quick, but there are other methods. So if we start here at Utrecht, then we want to get over here to Cleggan. So I've just highlighted them for myself because if you're anything like me, having like a C to end on, you could accidentally end up in Clifton instead of Cleggan, especially the CLs. So I've given myself lots of extra space here because I need to write in a few more letters. I may not use the full names of the places, but it will be as many as I need. Okay, I'm going to just use O here because there is only one O. So that's going to be our starting point. So where does it connect to? So I'm going to call it Leen, so we don't get confused. So I have 37 there. We have 29 here and 27. Okay, so there are three options. So I'm initially going to go here because it is the shortest. So let's bring that down to my next node. So if you want to work on your graph, you can start labeling that as node 1, node 2. They become locked in. Now, where can we go from this? So we can go over there. So we're adding on 53. So we have 27 plus our 53, and that's going to give us 80. And then we have harness, so I can get away with CA or. So that's 27 plus 58, and that gives me 85. Okay, so we have a duplicate of recess there, so we're going to get rid of the bigger one. So our next smallest working node we currently have is this one here. So that's going to become node 3. So, and that is 29. So then, where does that connect to? So it's quite a lot. So we have Karna again. So that's going to be 29 plus 23, which gives us 52. It also connects to Brownstone, which is going to be plus 20. It's going to connect to Clifton, which is 21. It connects to letter Frank, which is an extra 25. That brings us to 54. And then actually I don't even have enough space. And then we have this one here, which is 28 plus our 29, and that's going to give us 57. So first thing I want to look for is duplicates. So here's a duplicate. I have less. Here is a duplicate. I have less. Okay, so my next smallest node is here, and that becomes node 4. And that's 37. So connecting to that, I have 37 plus my 21. So it's going to give me 58. I have my letter franc, which is an extra 20. So that's going to be 57. And that's it. Okay, so let's look at our duplicates. Okay, a letter franc, we have a smaller version. Okay, we've no other duplicates. So our next smallest here have, sorry, some technical difficulties. So that is 49, and this becomes node 5. So our connection here, we have Anna, which is an additional 29 on top of the 49 that's already there. So that's 78. And then we have Clifton, which is an additional 18 on top of that. And that gives us 67. I think we have some duplicates. Yeah. So both of these are actually duplicates. So we're not going to keep either of them. So our next smallest is going to be Clifton this way. So we put that in here, and that becomes node 6. Okay, so that's connected to Cleggan, the one we want, with an additional 11. We also have letter franc, which hasn't actually been, we haven't locked that in yet. So it's actually fine to go back to that. And that is it. Now that is a duplicate and this is higher. So we are going to leave that one. Our next smallest is going to be kind of, so that is 52. And that will be node 7. Now, that is an interesting note because there's nothing that it's connected to that isn't already not locked in. So there's nothing we can do for that one at all. So our next smallest is going to be letter franc, which is 54. And that becomes node 8. And the only one that, oh, sorry, it's actually got 2. So we have an additional 6. And then Kragan, which is the one we actually want to get to, that's going to get us 69. That is already bigger than what we have. As is 60. So they are both gone. So our next smallest is this. That's 58. And that becomes node 9. And actually, that's not connected to anything else. So there's nothing we can do with it, which brings us to node 10, which is Pagan, which is this one here. So we need to think in terms of, okay, well, what is that path? So Pagan was from Clifton. And then if we go back and find our Clifton, Clifton came from Recess. And then Recess came from Utrecht. Okay. And that's our pathway right there. So our shortest path is Utrecht, which in turn goes to Recess, which in turn goes to Clifton, which in turn goes to Cleggan. You can see by the end of that, I would definitely be confused if I hadn't very clearly circled my endpoint. And then the total distance there is going to be my 61 kilometers. Oh, 61 kilometers. So part two asks us to describe how a network differs from a road map. So I'm just going to give you a big table here just to really compare and contrast what a network is versus a map. And what we're really seeing in this 2025 paper overall is an emphasis on students understanding what they're doing and what things are, as opposed to just blindly doing processes. So, what is a network? So, it is a lot of nodes with edges, and the roadmap really is a scale picture. And that's important. That roadmap having scale is one of its key features. So, a network is used to solve problems. So, it really is a tool, while a roadmap is more for real world. It's to help us understand where we're going. So for us in a network, those dots are only for illustration. There's no sense of the dot is representative of the location. But in a map, the towns are in their rightful places. So if you have something to at one town to the left of another, you know if the map is facing the right way, that means it is to the west. That's not true for networks. So for a network, there is no scale. It's all about just the connections. And then for a map, it's all about scale. It's literally somebody has taken the real world and shrunk it down. That is what a map is all about. For us, although we're really in a graph theory section, we're starting to lean a little bit towards topology, which is where we're thinking in terms of connections. And that's really all that matters. So then the edges, when we talk about a network, we're talking about those weights, and those weights could have time or distance or so on. We don't tend to see those with the road map. Instead, any roads tend to have like a name and an indicator. So something like M9 telling us the name of the road, and that name also includes like the type of road it is. RN being national or being regional, and so on. So for a network, we usually keep the lines pretty straight or simple. It's not that they can't curve, but we do try and make it look as simple as possible. Remember, it's all about the connection. However, in a roadmap, we want the roads to represent what the roads are like. We want to see the bends. We want to see the junctions. So if we think in terms of a network, if two edges cross, that doesn't really mean anything for us. We only care about dots and what goes into and out of those nodes. While for a road map, or any roads that cross, that has to be a crossing unless there is like a bridge indicated or something like that. So two roads that one goes over the other. So the distinction there is very important. And then for a network that they often use those very simple labels. Now I know we've just seen in that question that that's actually not the case, that they've used the full names, and that's quite unusual. It's more because I suppose the question and it's applying it to the real world. But for a roadmap, we would always see real place names. Okay. They don't tend to simplify them down hugely, and they tend to keep them exactly as they are. The dot shows the location, so then the writing can be put effectively anywhere. So you will be able to put a very good question, a very good answer together for this question. It did not need a huge amount. Um, I suppose what I will be answering for this about describing how a network differs from a roadmap, I will be talking about scale. That's the big one. So a network is not drawn to scale while a roadmap is. And that covers everything. Anything here from that table would absolutely suffice.